Welcome back to the talk on the industrial Internet of Things. Whether we are talking about the variables for health monitoring or we talk about the tracking of the soldiers, tracking of the drones that will go in the defense technology or so, industrial Internet of Things is all the rage nowadays. So there is a structure and elements of it. When I say structure, there are layers of industrial Internet of Things. If I try to name those layers, those are perception, network, processing and application. So I have first at the center central computing. Now there are 4 layers, as I said: perception, network, processing and application. Application is finally when you try to monitor your health, when you try to monitor the health of your manufacturing concern. Health of the manufacturing concern means your output or throughput of the manufacturing concerns, time saving, or you are trying to monitor any other systems such as the GPS system or so. That is the outmost layer, the application layer that goes out, maybe a smart city, a smart grid or so. It is central level or the perception layer that collects the data, which are the actual sensors, the actual systems or the elements that try to collect the data. Here we have cameras, the robots, sensors and some meters. We call it meter because the equipment used to measure the energy, that is known as energy meter. So what is the total energy, total power that is utilized for running this unit or maybe for running this computer. I can measure just putting equipment on the input wire or so, what is the energy that is being used. So those are known as meters. Sensors, there could be multiple sensors, it could be tactile sensors, there could be proximity sensors, IR sensors, temperature sensors or so. Then robots can do multiple operations, cameras can have visual inspection or visual or view or photographs of the system. So this makes my perception layer. Call it perception layer. So perception layer, it is all the actuators, all the devices like I have mentioned here, cameras, robots, sensors, meters, which are used to gather the data. It is referred to as edge layer or device layer. So in industrial Internet of Things, this is a very important layer where the controllers for the Internet of Things or the industrial Internet of Things are also taking part into it, and the process controllers are typically embedded and dedicated to a specific functions. For instance, a sensor that is, for example, temperature sensor, the function of that is would be only to record the temperature. That would be sent to a web service or sent to a cloud through a second layer that we call as network layer. We call it network layer. In the network layer, we have routers. Routers connect to Wi-Fi. That means we have Wi-Fi here. We have maybe other connecting technology or Bluetooth or any other, I would say, transmission technology. So this is network layer. Now network layer is the one which consists of dedicated IIoT devices that transmit the collected data over the internet. So following the flow of data starting from the smart sensors and moving up, this next layer provides an IIoT gateway. This becomes my IIoT gateway. So these are also known as edge gateways or so, which perform the local storing and processing of the collected data before sending it to the next level up in the network. Edge gateways are not only meant for process control, but also they perform these operations or some of the calculating operations while sending it to the cloud as well. Sometimes small cleansing also happens. So here the security measures are also implemented to shield or to secure downstream devices from any outside attacks as well. So data centers which are there, where we try to connect the data to the next layer, that is also taken care of to have a good security within them. Next come my processing layer. This is processing layer. So processing layer, we have web services in them. We have data centers, and we have cloud, where the processing happens. Now in the processing layer, we are in the main cloud domain now. At this point, the data has reached a database or a server in the data center, like Azure data center as there underwater also, as I mentioned. Large amounts of computing power are usually needed to execute the data analytics or the algorithms which are there in machine learning. Therefore, the most critical data or data processing that happens in this layer really. In addition to the regular algorithms, that is making programs or developing a small interface between the next application layer or so, this layer also includes web services. So in which all the cloud based technologies supports this process. So web service describe data transform from the device to the other interfaces of the programs. So it could be the markup language that you are trying to develop, so that gives you a final interface to the user. So it is the, I would say, interface to the user device. So it is an important point to note here that in the processing layer, the data is stored in the cloud, and when it is stored in the cloud, the security is higher, because at the local level itself it depends upon the security staff. The human intervention could also be there, or maybe the local computer is only storing the data. So storing it in the cloud or taking the data from the data centers through web services, so that is happening in the processing layer. So data centers are managed by a dedicated company, and security is much stringent than that is there in a local on-site system. Next comes the last layer, where we have the final devices that interface with the user, that is the application layer. Application layer refers to the graphical user interface, a GUI, that is deployed, which helps the operators, the users or the humans to interpret the information which has come as an outcome from the previous step. So in this layer, one can find user programs that generate reports, the analysis, the statistics, the plots, the graphics or so. There are many layers or many application layers in the market nowadays, but just to put or to name a few of them, it could be anything. We can have maybe a smart manufacturing system, or we can just have a smart home system. You can put anything: smart home, smart grid, smart infrastructure, smart city. So it could be anything like that. I would put smart city. So these are the major components of the industrial Internet of Things. Here definitely you could see, because so many things are connected, the data is to be transferred from one place to another. That this is structure and elements. Next is big data analytics in the industrial Internet of Things. The two domains, big data analytics and IIoT, are which are going to have a convergence and despite the fact that IIoT and BDA, each of them have been a subject of extensive research on their own. So, due to the high use of the sensing system and devices, it is widespread in industrial network nowadays. Big data production in IIoT is obvious. So, complete integration and implementation of big data analytics processes in the IIoT systems are not yet possible due to concept of the IIoT systems still being developed, because we are talking about industry 4.0 and this system is so getting mature that we are even trying to reach to industry 5.0, where completely digital systems would be there. That is, the minimal intervention of the human would be there. So, already IIoT adoption, the integration of these systems into edge cloud computing, the industrial marketplaces, so big data, virtualization technologies or technology advancements like to the central processing systems, smart manufacturing, these are already there. So, here I would like to discuss the structure of the BDA in IIoT. If I say BDA in IIoT, this can have various elements and sub elements in it. For instance, we can have sources of the data sensors, as one of the element. Then we have the analytical software, analytics tools or softwares that we discussed in the previous week. This is another element of it. Then analytical methods, it is not only the tools, what kind of models would you like to choose? Then we have what are the needs of requirements or conditions of the inputs. Then we have industrial analytics applications, that is also one of the element of it. And the types of the analytics. So, in the sources of data, the ERP, that is enterprise resource planning, the MES, that is manufacturing execution system, we have directly sensors here, we have SCADA program, that is the SCADA system which is supervisory control. And data acquisition. There are two kinds of data, supervisory and non-supervisory. By supervised learning or supervised data, we means you train the machine using the data that is well labeled, that is well tested, that is the data acts as a supervisor to the system or algorithm that is already tested. So, this is supervised learning or supervised based or supervised control data acquisition system. So, in supervised learning, the learning means training the data set by iteratively making predictions on the data and adjusting the correct answer. So, we collect the data, then we have CRM systems, that is the customer relationship management. So, these are just few of many sources of data production in an industrial setting. So, also here we could have the mechanical or IoT devices. So, here ERP systems give businesses the ability to use a system that is made up of numerous integrated applications, which helps to manage business requirements and automating as well a variety of back office tasks, which involves technology, services, and human resources. Next, the manufacturing execution system assists in maintaining a real-time record of the manufactured data and receives and up-to-date information from robots, machines, and IoT devices. So, it is real-time record. Next is SCADA. The supervisory control and data acquisition system are used in industries to monitor and manage a facility or maybe a piece of machinery, for example, telecommunication, maybe water and waste control, energy or in the pipeline, maybe oil or gas refinery or transportation. So, these try to control machinery. The MES systems are connected with machines and Internet of Things. Next, CRM systems. CRM systems are frequently employed to manage the client relationships, customer relationship management. That is, industry are using these devices to carry specialized tasks which produce a massive amount of data every day. So, client understanding. So, what does the client need? How do we serve them? So, by using analytics tools to the data gathered from different or these mentioned systems or machines or the devices that we try to use, useful information can help in decision making, and the data that is extracted from here could be used to have an good processing over it, where we use BDA and try to have a decision out of this. So, these acts as a decision support systems for the internet or the industrial internet of the things. So, this is point number 1, sources of data, which is discussed here. Next is point number 2. I will just name them 1, 2, 3, 4, 5 and 6. What is analytics tools? Point number 2, the analytics tools, which could be the analytics software, or the algorithms repository, visualization tools, maybe then data modeling, and online analytics packages. Hola. But to gain understanding from a sizable amount of the industrial data, a variety of analytics tools are needed. These tools include the modeling software, online packages, the visualization tools, the modeling tools, or the software or the online analytics packages. Analytics software helps us to have a predictive output. That means it helps us to forecast the unforeseen events. An algorithm repository helps us to keep a record or collect the programs or the algorithms which were created by the data scientist or which were created by the analysts and which were guided by data engineer, which were supervised to some small extent, and which were not used in past or which are sometimes tested in the past as well. So this repository helps us to keep a record, I would say, collection of programs or algorithms. So which set of programming languages were used, which set of the standard user interfaces were there, those all helps in have a kept proper record of that, and we can use them or retrieve them whenever required in the future. The tools for visualization, these help in presenting data in the different formats. For example, infographics, right, or maybe the dials, the gauges which were developed, or maybe the geographical graphs, the heat maps, the tail bar, the pi and fever charts or so. All these helps us to keep a record of the graphics or the plots which were made in the previous tests or previous runs. So within the context of the corresponding information system in industries, the modeling tools plays an important role which are used to define and analyze the data requirements for supporting the business processes. So web traffic data is tracked and analyzed using OLAP. So this is the analytics tools. However, they are also one of the subsystems of the big data analytics in IoT as a complete system. So these subsystems have subsystems, and these subsystems do have elements in them which are listed here. Next comes number 3, that is the analytics methods. Analytical methods, if I try to talk about, there are numerous methods which can help in extracting a value from big industrial data, which enables quick and effective decision making. Now, it could be ranging from text analytics, then machine learning, data mining, general statistics, or maybe the text language or natural language processing. So, through the use of statistical pattern learning, the text analytics reveal patterns and trends that help to generate high quality information. Patterns and trends. This has been elaborated in the previous lectures as well. Now, how Internet of Things helps us to collect the data, that is, how do we try to have to track them if the programs are made to collect all the information regarding the specific product review that the person has given, or the specific product, multiple reviews of them people have given. So, what are the trends which are coming, what are the demands that people are expecting, or of people who are returning to the Amazon or returning to a Flipkart. So, why is the product being returned? They always ask the reason for that. They have a listed checklist, and from that checklist they also ask the following questions, that what could be the reasons, what do you expect in this product, was it not fulfilling your basic requirement, or did you change your mind, or do you have a similar product in a lesser price or so. So, these patterns and trends could be tracked in text analytics when we use analytics methods in connection to the sensors or the equipment or the machines which are there in my industrial IoT. Then machine learning means the systems can go into the self learning phase. Without having used to program them time and again, the AI systems are being developed. Now, enterprises can convert an unstructured data into the useful knowledge with the help of data mining solutions. It helps us to have unstructured data to useful information. On large scale industrial data are gathered, summarized, analyzed and interpreted with the aid of the statistical tools. Large scale industrial data like I took an example of the data collected for the heat or the temperature that is collected each second of the run of the engine. Do we need to have data for each second? Data could be collected in each millisecond as well, but do we need that? Can we have an average of 1 minute? If that is an average, that is a statistics. If in that average, what is the variation? We try to have a standard deviation in that, that is the statistics. If from that average we try to say at what points the average is higher or lower, that also becomes my statistics. So, large scale industrial data could be summarized to be what is useful only using the statistics. So, that is why analytical methods always have statistics as its one of the important subsystems. Now, NLP, natural language processing systems, so these are used in an industrial setting to extract an unstructured data that is in the form of language. Next comes the needs or the requirements that the system has. In the needs or requirements, we have with us the first one as the maturity models. Then we have the architectures. Architectures specifically functional. What are these? Let's talk about them. Then architectural, which are in infrastructural architectures as well. And integrated analytics. In these, what we have is, we have to create new analytic systems for the industrial IoT, where certain needs should be taken into the consideration right at the time, right in the beginning. The models of maturity is one of them. Analytic system capabilities can be measured and tracked with aid of maturity models. So, these aid in quantifying the effort need to complete a particular stage of the development. That means, we try to set boundary conditions, set boundary, I say walls or conditions of where the model is going to be mature, then quantify the effort required. So, these models aid in keeping an organization's big data program in a good shape. That means, the system is planned, the model planning is done, where to close the model, what is the hypothesis, what size of the data we require, what will be the size of this sandbox that we have developed in analytics is there, that will be helpful. Now, architectural model, that is the functional architecture, aids in defining the roles and responsibility between the functions of analytic systems. That is how system components cooperate to carry out a specific system mission, which means analytic systems should be created to handle a massive amount of data in real time in an industrial setting. Cooperation between different functions. This is important. Now, in this situation, when the cooperation between different functions are required, infrastructure architectures also play a big role, because designing a big data infrastructure from the pre-existing equipment using an industrial paradigm requires experienced scientists. So, because we have to use existing system plus experienced staff to handle them. Staff means the data scientists or data engineers or the big data analytics team, which are gonna use the present infrastructure architecture only to develop a team out of it and to develop an analytics system out of it. Now, supporting the integrated analysis is also one of the needs, where various types of industrial IoT data is considered as one. So, it becomes a main requirement of a complete analytic system. I would say combining different industrial IoT systems. Next comes the types of the analytics. In the types of the analytics, we have the descriptive analytics, predictive analytics, prescriptive analytics that was discussed in the previous lectures. Also, now along with the prescription and prediction, real time monitoring, where we describe the things live, that is in situ inspection or in situ control of the systems. We have the real time analytics as well. Decision support system for the real time and taking the decisions therein. So, these four kinds of analytics are there. So, understanding the historical data is the purpose of descriptive analytics. with number of defective items in the past and the reason for the defects or so. So, this is all descriptive analytics. So, if I try to project that into the real time analytics, we could also mean to have maybe the current items. I would mention it first here, current status or current location of a product or a fault or product, comma, defect or fault. Predictive analytics is anyway the prediction that is what is going to happen in advance, that is forecast or advance prediction of potential problems. Prescriptive analytics, last but not the least, advises or suggests the best course of action. Would say best possible course of action. So, that is whether the machine is receiving right material or not, whether the machine performance is consistent since the beginning or since the morning or not, whether in the morning itself the performance might be higher because the worker is fresh to work upon, in the evening hours whether performance is coming down, whether that is due to the human error because the worker is down or it is because of the machine has got heated up, or between the change of the setups do we have the pilot piece or the first piece that has been manufactured just after the setup change tested or not. So, do the output or do the data that is generated for the pilot piece same as that is being produced for the other pieces as well or not. So, this all is prescriptive analytics, the best possible course of action, what could we do if the problem is there. So, this becomes my types of analytics that is there, and kinds of the analytics also decide what kind of the sensors or what kind of the data models are we going to use. So, this anyway is the simple big data analytics which we are now connected to different sensors, and different sensors are helping us to collect the data in the different layers which are discussed. So, in the network, in the processing, in the application, the data is being collected in the different applications, and finally in the applications whether we are trying to have a smart manufacturing system, it could be completely transformed factory or maybe one site or one element of the factory is only changed. So, if a small change has happened, we can say yes, the color of the factory in the terms of the greenness, in the terms of the smartness was black first, it has not turned to complete green, but from the black it has turned to grey color or so. So, if the small portion is only changed. One part, industrial analytics applications, that is also important, which also I will like to mention here. Number 6, in which we have different kind of the applications of the industry, that is whether it is manufacturing or operations, or it is the supply chain, and supply chain we can also call it logistics or the movement of the material, whether it is in the form of the raw material, work in progress or finished goods or packaging, this is all logistics here. Then in sales and marketing, also research and development. Now, these kinds of the different functions of the industry, whether in manufacturing, supply chain, sales, marketing, research and development, are to be taken into account. Which function are we targeting? The machine performance history. In the manufacturing and operations, I have taken certain examples. For instance, the previous history of the machine. We can have a maybe predictive analytics here as well. So, whether rescheduling is required or maintenance is required or machine failure is there, that all becomes a part of the manufacturing or the operations of the system. So, in this decision support system, it can aid in industrial or controlled or manufacturing decision support system. The logistics and supply chain can benefit greatly from effective application of analytics, for example, condition monitoring, then supply chain optimization, fleet management, strategic supplier management. This all becomes the kind of the applications, industrial applications that our industrial IoT is having through big data analytics. In sales and marketing, analytics tools helps to allow the business to foresee or increase the future sales. For example, to help in determining the seasonal trends that can lead to developing an adaptive marketing strategy. In research and development, analytics tools can help to identify the defective components, maybe through sensors, whether the component is defective or not, should it be shipped to the customer or not. Even after being shipped to the customer, the test could be taken by the sales manager or the after sales manager there itself. So, we can identify defects. Right, using sensors. So, this helps us to develop a better OC curve, that is operations characteristics curve. So, this was a brief introduction or the broad discussion on big data analytics in industrial IoT system. So, I would like to discuss case studies in the next lecture, where we will see how industrial IoT is being supported by big data analytics to have an output which industry has proven to be very helpful or very profitable to them. Thank you.